Phone. Our first speaker for this session, and in this session we are talking about what does it say? We are talking about managed and staged objects. Caches and execution points is the name of the session. Todd Miller from CHTC is going to kick it off, talking about files common across jobs and how to transfer them.
So had I known the session was going to be called Objects, I would have used that in the title instead, but I think you're all more familiar at this, right now in terms of thinking about your jobs using files. So when we talk, that was the wrong button. That's why that didn't work. When we talk about files common across jobs, I think we all have a pretty good intuitive idea that we're talking about files that are required by or input to more than one job. Nice and simple. Condor thinks about this in a almost equally simple way, but doesn't really assign any value. It just says it's a list of object names, by which, of course, we mean locations, the same way you would specify them in a normal job submit file, and a name for that list. Just to keep that in mind. Throughout the rest of this talk, I will actually be talking about common files rather than files common across jobs. Now that I've defined that, it's a lot easier and faster to say common files. Of course, you might wonder specifically which files would those be. My understanding is that Pegasus already knows the answer, even if we don't, and we don't have any analysis for it. There's some kind of a no-brainer answer here maybe as well. Container images are a great example of something where we know that they're read-only. We know that a lot of jobs use a lot of the same container image frequently. But I'm really kind of actually hoping that in practice, Pelican and the caching infrastructure it comes with have already addressed this as a practical matter, and then it's not really a big issue for people moving forward these days. So instead, I'm going to be talking about how to transfer these common files and just do so once. I'm going to talk initially about the grab your present. This tech demo was a great way of phrasing it that Todd used in his talk yesterday. And then talking about how we want to shiny that present implementation up, make it look good in the future. Ask everybody here a few questions, prompt you to think about a few different things, get back to us about those. In summary, the current implementation is a very limited mechanism and only a mechanism. So there are no policies, there are no knobs. There's nothing about scheduling in this tech demo that you're going to see come available towards the end of this month. The current implementation requires explicit specification of the common files. So that we're not trying to guess what they are by looking at your jobs. We're not trying to be clever. You just go ahead and tell us what those files that you know are going to be the same across all of your jobs, or excuse me, across a small set of your jobs. I'll get to that in a second. And right now, the mechanism can only share common files among concurrent jobs, which is to say jobs that are running at the same time on that same EP. The intention here for this tech demo is experimental, right? I'd like to get some help from our users testing the mechanism with real workloads and real situations. I would like people to abuse that mechanism, bang on a little bit, see what pieces fall off. And that's not just so that I can roll the pieces back on, but so that you can tell us a little bit about how well we handle failure in the real world and about how obvious it is what's going on. And of course, then use that experience to help inform our discussions about policies and knobs for or about scheduling. Of course, being a tech demo, it's got a bunch of other limitations. Primary one here, although hopefully not one that'll matter a great deal for the experiment, it only works on vanilla universe jobs right now, and only on EPs which are not enforcing disk limits. That's kind of an embarrassing pair of limitations. It specifically does not work with container universe, but that's an engineering effort issue and not a technical problem. It only works for jobs in the same cluster. That's to simplify that naming issue and deciding what the scope of those names are. They're limited to that jobs cluster right now. It's limited to objects which are read-only during the job's lifetime. So that if you have some way of updating them between jobs, go ahead and do that. That should work fine. But while that job is running, they need to be read-only. It doesn't work on Windows. Engineering effort, nothing interesting there. Be aware when you're running your tests that you don't get any benefit with the current implementation if the common input files that you specify are in the input list. To help keep things simple, we don't try to modify the transfer input list to reflect what may or may not be available as common files, what may have already or not been pre-staged. So when you run your experiment, I'll have a slide in a little bit here that has the whole example job. You're going to have to add this has common files attribute that new EPs will be advertising to make sure your job runs correctly, because its transfer input files will be missing some of the things that it needs. And as I mentioned earlier, of course, you need an EP that can run more than one of your jobs from that cluster simultaneously. I mentioned that because that was kind of where we originally started with why we wanted to look into doing this in Condor, was that we have submitters or would-be submitters who have jobs that have such a large input set that in practice, we can only get one copy of it onto the EP at a time. That might be an EP, suppose these are AI training jobs that has 4 or 8 or 12 GPUs in it. But we can only actually use one of them at a time right now because we can't get an extra copy of the job's data in there. And we didn't have a mechanism for sharing it among jobs that were running on the machine at the same time. So Condor wanted to do this. We wanted to do this as the software suite developers, because this isn't a problem that Pegasus or Pelican or other collaborators can actually help us with. This is a scheduling problem that we need to handle internally. This brings up another limitation. Despite this being our motivating example, this doesn't work automatically right now. Same sort of reason as before. If you request enough disk to fill up that whole EP, we don't actually subtract off the common files that are in there, and they've been pre-staged already for you automatically. So to run this particular experiment right now with this implementation that's coming out in 24.9, you'll need to cheat a little bit. Example slide I promised you, the my.common input files. There's no formal UI or UX here. That's another thing that we're going to really want to get a lot of feedback on, make sure that this is actually usable for our submitters. And then the requirements expression there, presumably your actual requirements expression is more complicated, but all you have to do is add this clause in. Briefly wanted to make 2 points about the current implementation's transfer logic. The first one is that the starter starts out now. It spins up, does a little bit of bookkeeping initialization, and then asks the shadow what it should do before it starts trying to transfer files. And that is a big change. If you were here the whole week, we mentioned, unfortunately, I don't remember on which day, earlier that we're trying to kind of invert this control flow where the starter sends some data back and then gives very strong recommendations about what the shadow or what the AP should do. So this is a part of that work. If you've been tracking what we've been keeping closer track of what we've been doing in the development series, you'll remember we added a feature and then the ability to do this after input transfer. We used to do some error handling and make things better in that respect. And this will have similar benefits where we can use it for other features as well. The transfer logic here, I've actually simplified a little bit. It's a little more complicated than this in reality. The key simplification, I'm asserting here by talking about the first shadow and then the subsequent shadows. So first and subsequent jobs would be another way to say that, that we do have a very strict ordering. Of course, you're aware that we can run multiple shadows literally at the exact same time on multiple different cores. We're going to ignore that problem for now. If you're curious about how we got around that, I can talk about that in the question time. So it's that first shadow. It knows that it's the first shadow. When the starter connects up and asks, what should I do? It says you should start transferring common files. Every subsequent shadow says, oh, okay, that first shadow is transferring the common files for me. You should hang out until it's done. Then when they're all done, they go ahead and map those staged common files into the job's initial working directory, where they expect those files to be as if they had been transferred as part of the normal input transfer. Then, of course, we continue on and start the job as normal after transferring the proc-specific transfer input files. Second key point I wanted to make on this slide is that this sequence means we didn't have to do any clever scheduling right away. I told you this was just a mechanism and that was no policy involved. And that's because when we get this, it's because we only transfer these common files when we are sitting with the resources ready to run the job. So there's no worry that we're going to waste any work by transferring the files and then not having the resources available to run the work. We don't have to keep track of anything separate. It's just over the lifetime of that first job. And if we get another slot on that same machine, we can run another job during its lifetime. Great, we can save some bandwidth. As I mentioned, this tech demo will be released in 24.9, as you've kind of inferred probably from what I've been saying through the talk, effectively without a UI or UX. In the immediate future, so in 24.10, hopefully a month after that, so late July, is to make common file transfer as observable as input file transfer. No technical issue here. Common file transfer uses the exact same mechanism of that normal input file transfer uses. So we've got all the data we could possibly want. Well, maybe. We've got all of that data. You can get the same error messages out. It just needs to be wired up. The interesting question here that I want to hear back from people who use the job or user event logs. We could certainly write, and it would be legitimate to write two separate transfer events, transfer input events for each job that does common file transfer. That could be really confusing to some scripts. It might be equally as bad instead to have a custom event that this is a common file transfer. I wanted to let you know that was happening. I don't have any particular preference off the top of my head. I'd like to hear what people who are actually parsing these logs and using them in their workflows would prefer. Obviously, we're going to want logging in the shadow and the starter. That's already ready to go. I don't think there will be any need to have specific entries in the job ad about what's happened for common file transfer. If you guys come up with a reason for that, do let me know. Perhaps most importantly, I haven't wired up the error reporting correctly yet. That should be pretty straightforward. Hopefully that'll be, I expect that to be available in 24.10. You're not going to get identical error messages because, of course, I want you to be able to tell the difference between common file errors and transfer input errors, but as close as possible. A little bit further in the future, we do want to think about implicit definitions of common files or automatically determining what they are. The big deal there, I think, is going to be that we don't know and can't tell just by looking at a job ad if those files are read-only. That may require then using a copy mechanism so that we save bandwidth over the network, but we don't actually save any disk space at the EP if we're doing this discovery automatically. Excuse me. Of course, we also want to allow common files to work between clusters and not just within them. We need to be really careful about the scopes if we allow you to just assign explicit names. So that I want to do some more careful thinking and working through before we allow that. We may have an intermediate phase where the automatic naming system that's in place right now becomes aware of DAGs, and that becomes something that works with less user intervention. I'm going to skip the next 3 points. They're basically just repeating, the limitations I told you a few slides ago, we would like to get rid of. There's not much in the way of technical issues here. Again, it's just a matter of engineering effort. The last two things, last two things I want to present today, the sequential reuse as something we really want, and then improve scheduling, which is basically actually a series of questions about what we should be doing, and trying to prompt some thinking from our users in the audience here. The idea for sequential reuse, remember the mechanism right now only works for jobs that are running at the same time on the same EP. We would like to do something very much like Dagman, where we have this keep claim idle idea. If it takes a few seconds or a minute or two to get another job out to that EP that uses that same common files, that's probably worth waiting for. And so the idea here is to change the lifetime of the common files that we've staged from the lifetime of that first job to the lifetime of that claim, which is to say for how long the AP that those common files came from gets to hold on to those resources on that EP. Basic idea here, of course, is that the shadow is going to keep the starter alive. We wanted to make this an AP side operation rather than get any help from the start D here, so that it can maintain its claim on the disk resources that are holding those common files. The hard part here, and why this isn't already available, we don't want to hold on to these to hold on to all of the resources of the slot. We just want the disk. We know that we have enough resources to run another job that uses those common files even, but we can't start a job if we're holding that old starter open. So we want this ability to tell the start D, I'm done with everything except for this amount of disk over here. Please make a new slot. Let me hand it off to the shadow. Let me hand it off to the AP. Let it run a new job. lots of different options for mechanisms for improved scheduling, which I've not included here because they're all extremely speculative. And the real questions that we need to answer are about policy. What do we want to do in terms of scheduling? Scheduling common file transfer. And then kind of a similar question, what can we do given that in terms of whole pool scheduling, fair share priority happens first, right? This is not something that's easy to work around in the slightest, where we would have done it by now. Another question to ask, to consider might be which daemons get a say. Obviously, the AP has the final say in this matter, but I can see situations where it'd be really useful to have an EP that could be told, you have an unusually high ratio of cores or GPUs or memory, computational resources to bandwidth. I really want you to very strongly prefer jobs that transfer common files, and then just very strongly prefer jobs that follow up and use that staged common files so that you make the most efficient and best possible use of your bandwidth. Of course, when we talk about which daemons get to have a say, we're talking about which people get to have a say. So there are a bunch of different stakeholders here. Probably everybody in this room has something interesting to say about it. Our normal solution to problems like this is matchmaking. I don't know that that operates on a fast enough scale. Oops. Nope, that's actually, sorry. For this problem. For efficiency reasons, we do a lot of slot reuse, where a job finishes, the AP holds on to those resources and uses them to run some other job. That's what slot reuse means. In a lot of pools, that's something where we might hold on to a resource for 12 hours or 24 hours or longer, and not get a chance to reassign resources based on something like where the staged files have gone. So my question here, to almost end this talk with, suppose we have a sequential reuse that I can hold on to these common files and then run another job from that cluster, then run another job from that cluster. Maybe we're talking about the OS pool, where I think the average lifetime of a glide-in is about 4 hours. Average lifetime of a job, I think, or I hope for this example, is about an hour. It says to me we should be able to reuse those common files 2 or 3 times without having to do anything at all. If we just have a strong preference for shipping jobs from that cluster one after another to that same EP. Savings of a reduction of bandwidth usage for those common files to a quarter or a third, that might be enough for the efficiency gains we're looking for. So I'm kind of interested if that works, if that will work out in practice, what people think about that as a first approach. If you have any answers to the questions I've asked, I would love to hear them now or later. Otherwise, if you have any questions, I'm pretty sure we've got plenty of time before the next talk. And in either case, thank you very much for your time.
Thank you, Todd. We do have a bunch of questions from a bunch of people.
So more of a quick comment, but Todd, OS pool glide-ins are generally 1 to 3 days. So I would expect
my mistake. Okay.
Yeah, fair amount
better.
of opportunity for reuse.
Yeah.
Also, the facilitators tell researchers, try to keep it within 10 hours. So, jobs are a little longer, I think, than you were thinking, but also the potential for reuse might be a little longer.
Okay. Thank you.
Just a quick comment about read-only files. I think having a first principle notion of these input transport files are read-only, and that would be useful just by itself, because sometimes I just want the files there. It would be nice if they were written on file and marked as read-only, so I cannot screw up myself. So a user often knows that this file is read-only. So if you actually protected it from my accidental abuse, that would be useful independently of the reuse concerns.
It's interesting. Obviously, we do preserve the read-only nature of files we get from the disk, but if we're pulling something from OSDF, I don't think we have that information. And so, yeah, I think that would be useful. I think that actually follows up really nicely for people who were here for Greg's talk yesterday with the idea that we can have this more functional programming approach to our distributed computing solutions. And one of those is being able to mark things as immutable. Yes, thank you.
Go ahead, Christina.
How are the common files removed?
When currently, when the job, that first job that I talked about, well, when it ends, it cleans up its whole sandbox, including the common files. Now, the other jobs can continue to run because of Linux file system magic. As Todd mentioned yesterday, hard links. Until you remove the last of the hard links, the data remains available. That does limit somewhat because it means that every execute directory has to be on the same file system. In practice, that's usually true, and so I didn't think it was worth mentioning explicitly.
So when the last activated job using any of those common files is deactivated, that's when it's cleaned up currently.
Okay, so if, let's say I have a job starts, does common files, so it's the alpha job or whatever, and then other jobs start and they have hard links to that common data. So even if alpha job finishes, that data is removed, they can still operate. What if that alpha job finishes and another job using those common files gets matched to the same node and the common data isn't there to form hard links? Does that matter?
At this point, mostly to keep things simple, and because of this sequential reuse problem, where we want to make those resources available to other jobs. Right now, as soon as that alpha job goes away, we start claiming that there aren't any common files available. And so the next job to start running there will have to transfer it again, which is a little unfortunate, but
But right, a future revision will have it under AP control, right? So that
My vision at the moment is that it's limited to a job list. There is an entity that understands that these files are common to everything in this entity, and the AP is taking advantage of it. I am extremely reluctant to be smart about, I know that you are using the same file as somebody else, and I'm going to give you that file, because that will lead us to disaster. So at the moment, the vision is when you give me a job list or a set, and you say all the jobs in this set are using this common input file, then we are going to stage it. Otherwise, nothing smart and nothing sophisticated, and it has to be explicitly visible that this group of jobs is using this data. So because once we become smart and do caching and we know what you want to do, we will lead to a disaster.
any other questions for Todd? All right, let's give him a round of applause.